Okay, so we've got a function that is continuous on the closed interval from a to b, including the ends. Differentiable, because there's no sharp corners or gaps or anything, or cusps. That's a sharp corner. Then it says, then there exists a number c in the interval from a to b such that the derivative at c is equal to, now I want you to think about what this is. F of b minus f of a. What are we subtracting here? What kind of values? Y values. Isn't this y minus y of the ends? Over, what is a and b? X minus x. That's the formula for? The what? Slope. Slope is derivative, right? So it's saying the slope between the two endpoints, the slope of the line between those two endpoints, that slope is f of b minus f of a over b minus a. That's this side. You're finding the slope between the two endpoints is the same as the slope at some point along here. So I can find that point is C. So like right here, if I draw the tangent line right there at C, at that x value, wouldn't it be exactly the same as the slope between those two endpoints? That's what the mean value theorem is saying. That if you find the slope of a function between the two endpoints of an interval, you'll be able to find some value C in between a and b where the slope at that exact point is the same. So what you're actually looking for is you are looking to find this value. Find this x value. And the way you do it is you basically just set this equation up right here and solve it. And I'll show you exactly how to do that in two examples. So we have two theorems. We have Rolle's theorem, which you have to check continuous, differentiable, and the endpoint y values are the same. If that's the case, then you can find a place where the derivative is 0. We have the mean value theorem, which says that if your function is continuous and differentiable, and you find the slope between the endpoints, you'll be able to find a slope, a place where the derivative has that same slope. So let's look at a couple of examples for the mean value theorem, and then you'll even have time to start your homework. So the mean value theorem, let's take a look at apply the mean value theorem to apply the mean value theorem and here's our function f of x equals, yes, I sure can, thank you. So apply the mean value theorem to this function f of x equals, you want an easy one or a hard one? Hard one? Easy? Maybe we'll do two. I'll do one easier one. And then one that's maybe a little harder. So we would like to apply the mean value theorem, and basically what they'll ask you in the directions is to find the values of C. And you probably won't ever put C in, okay? But if you recall, the mean value theorem, it says f prime at C, f prime at some number in between a and b is equal to the slope of the end. So you're looking, basically you're going to set the derivative equal to the slope of the endpoints. So first I just have to check, is this function continuous and differentiable? Is f of x continuous and differentiable on the interval from -1 to 1? What is this? If you distribute, you'll get like an x cubed. So it's like a polynomial. Is a polynomial continuous? Yeah, it is. You could graph it on a graphing calculator. It's going to be a little wavy thing up and down. It's going to have two curves, up, down, down, up, down, up. That's what it's going to look like. So is it continuous and differentiable on 1 to 1? Yes, since it's a polynomial. Okay. All right, so now we can apply the mean value theorem. So to apply the mean value theorem, I write the mean value theorem, which says f prime at C is equal to f of b minus f of a all over b minus a. So now here's basically what's going to happen the way you're going to do this, what it's going to look like when you do it. Your c is going to be x. What's your b value? Your b value is the end of your interval, 1, and a is negative 1. The interval they give you is the a and b. So all I have to do, f prime of c, well, c is going to be x. Do you know how to find? That's just the derivative. Derivative of the function. That's all you're going to put there. You're going to take the derivative and put it right there. So what's the easiest thing to do to find this derivative? Could I distribute and power rule? So if I distribute, so I'm going to distribute right here. So f of x is x cubed minus x squared minus 2x. So what's my derivative?
3x squared minus 2x.
Good. So there's my derivative. And now over here I need to work out f of b minus f of a over b minus a. We plug in a and b. So f of 1 minus f of negative 1 all over 1 minus negative 1. We're just plugging our endpoints in. So how do you find f of 1 though? Put 1 into the original function. So here I distributed the original function here. Can I plug it into the one I distributed? I could plug it into either one. It doesn't matter. They're the same thing. So 1 minus 1 minus 2. 1 minus 1 minus 2. Negative 2. So I've still got this derivative over here on this side. I'm plugging 1 into the original function and I get negative 2. If I plug negative 1 into the function, what's negative 1 cubed? No, it's negative 1 minus negative 1 squared. So negative 1 minus 1 is negative 2, and then that'll be plus 2. What do you get there? 0. All over what's 1 minus negative 1? That's 1 plus 1. 2. So the whole right side works out to be what number? Negative 1. And how am I going to solve that for x? Now solve for x, which is your c. Which is your c. So how am I going to solve that? Get it equal to what? Get it equal to 0. Factor it. Separate. Okay? So this is algebra 2 here now. So add 1 and I get minus 1. Let's hope I can factor this. If not, I could use the quadratic formula. I could complete the square. We have all kinds of options. Okay, so how do you split up 3x squared? 3x and x. Okay. How do you split up negative 1? Positive 1, negative 1. So negative 1, positive 1. Did I factor it right? Well, how do I know? I check the outer. 3x minus 1x. Does that give me the negative 2x that I need? 3x minus 1x, is that negative 2x? Nope. So what do I have to do? Switch the signs. That should be plus 1. That would be minus 1. And now it'll be negative 3x plus 1x, which is right. Now I separate this and say 3x plus 1 equals 0 and x minus 1 equals 0. So what solution do I get from this part? X equals negative 1/3. And from this one, 1. Which of those is in the interval? In the interval. What was my original interval? Interval was negative 1 to 1. Which of these is in the interval? Negative 1/3 is. Why wouldn't 1 be the answer? It is an endpoint. If it is an endpoint, it's not within the interval. So the correct c value is negative 1/3. And if you just write x as negative 1/3, that's fine with me. Win. All right. I'm going to do one more of those. So apply the theorem of the mean. apply the MVT. That's how they abbreviate it a lot of times, apply the mean value theorem. All right, so this one, I would like one that is a fraction. So f of x equals x over x plus 1 on the interval from -1/2 to 2. So I would like to apply the mean value theorem to this function on that interval. All right, so is this function continuous? No. Where is it not continuous? Not continuous at x equals -1. But what? It's not in the interval. It is not in interval, so we're fine. If it was in the interval, what would I do? Would I keep going? Would I apply the theorem of the mean? No, you wouldn't. You would say the mean value theorem does not apply. Okay? So it is continuous on the interval. So yes, initially you were right. Is f of x differentiable on the interval from -1/2 to 2? Well, I might need to find the derivative to figure that out, don't you think? Or I could look at a graph and see if there's sharp corners, but aren't I going to have to find the derivative anyways for the mean value theorem? So let's just do it now. So f prime of x is, what rule are we going to use? Quotient. So x plus 1, the bottom times, what's the derivative of the top? 1. Minus the top times the derivative of the bottom, which is 1 again, all over the bottom squared. So if I just on the top is basically just x plus 1 minus x. So what's my derivative? What's on top? 1 over x plus 1 squared. Is there any place where that is not defined? Not defined at x equals what? What number can't you put in for x? You'll get 0 on the bottom if you do. -1. But we're okay still, right? We're still okay? Still okay. Not in interval. You have to check this stuff, because you know what? Some of your problems, you can't apply Rolle's theorem. You can't apply the mean value theorem because it doesn't have all the givens. So if you just jump in and start using the formula, it's going to be wrong. You have to check these things. All right, so can we apply the mean value theorem? We can apply the MVT. All right, so now we need to actually apply it. So on the next page, I'm going to write the mean value theorem. F prime at C equals F at B minus F at A all over B minus A. So what's my A? -1/2. What's my B? 2. What's my C? X. So we already found the derivative, didn't we? What was our derivative? -1, or is it just 1? 1 over x plus 1 squared, okay, equals f of 2 minus f of -1/2 all over 2 minus a -1/2. So what's f of 2? Put 2 into the original function. 2/3. -1/2 into the original function. So let's see, that's -1/2 over 1/2, or -1. And then 2 minus -1/2 is 2.5 or 5/2. So what I have is 1 over x plus 1 quantity squared equals 1 2/3 or 5/3 divided by 5/2. And what's 5/3 divided by 5/2? 2/3. Don't the 5's cancel? Multiply by the reciprocal. 2/3.